Let's say you've got a system of equations, and one of them is a linear equation, so it's going to graph a line, and the other one is a standard parabola equation, so it's going to graph a parabola. So how many possible solutions are there? Well, let's look at all the different possibilities. So here's my x and y axis. I could have the parabola going like this, and the line going like this, so we could have two solutions. Or I can have the parabola going like this, and the line tangent to the, whoop, just missed it, didn't I? And the line tangent to the parabola, which means I would have one solution. Or I could have the parabola going like this, and the line completely missing the parabola, which means there would be zero solutions. Okay, so depending on what conic section you're working with and how they are graphed in relation to each other, you can have any number of possibilities. For example, how about with an ellipse and a parabola? Well, I could have the ellipse going like this, and the parabola going like that, and in that case we would have 1, 2, 3, 4. Or I can have the ellipse going like this and the parabola going like this, and in that case we'd have 1, 2, 3. Or we can have the ellipse going like this and the parabola going like that, and in that case we just have 2. Or we can have the ellipse going like this and the parabola just tangent to it, which means that we would have one solution. Or they could miss each other completely, which means we would have no solutions. Okay, so with an ellipse and a parabola, you could have up to 4 solutions, or you could have 3, or you could have 2, or you could have 1, or you could have 0. So it just depends on what you're graphing. Alright, so what are we going to do to find the solutions to these systems? Well, we have an algebraic method. We actually have two, and the first one we're going to learn is elimination. So let's use elimination to solve this system right here. This is actually a parabola and a circle, and you'll notice that if I add these two equations, the x squared is going to drop out completely, and I'm going to get y squared plus y equals 2. Getting everything over on one side, I get that, and that will factor. That'll be y plus 2 times y minus 1. So y is equal to negative 2 or 1. All right, now let's take these values and plug them into that first equation, okay? So I've got negative x squared equals negative 7 minus y, or x squared equals 7 plus y. And if I plug in negative 2, I get x squared equals 5, which means x is plus or minus the square root of 5. And if I plug in 1, I get x squared equals 8. So x is plus or minus 2 root 2. So how many solutions do I have? Well, I got two x values when I plugged in negative 2 for y. So that means I get two solutions there, plus or minus the square root of negative 5 when y is negative 2. And I got these two x values when I plugged in 1 for y. So I have two more solutions there, which means I'm going to have a total of 4 solutions. And here you can see what the graph of this system would look like. So this one is at negative root 5 comma negative 2, positive root 5 comma negative 2, and here is negative 2 root 2 comma 1 and positive 2 root 2 comma 1. Okay, let's do another example. Let's solve this system using elimination. If you'll notice, once again, if I add these equations together, the x squareds drop out, which is very nice, and I get 2y equals 8, which means that y is 4. Okay, let's plug that into the first equation. So x squared plus 4 equals 3. X squared equals negative 1. If we're trying to find real solutions, that's not going to give us any answer. So there's actually no solution to this system of equations. Now let's take a look at the graph of them. And you can see that it's two parabolas that do not intersect each other at all, so that's why there's no solution to this system. And let's do one more example. This time, instead of doing elimination, we're going to use substitution. Okay. Now if you look at that second equation, you'll notice that y is equal to x plus 1. So I'm going to take that x plus 1, I'm going to plug it in for y in the first equation. So now my first equation becomes x squared plus x plus 1 squared, because whatever y is being squared, equals 5. Okay, let's multiply this out. X plus 1 squared is x squared plus 2x plus 1. And combining similar terms and getting everything over on the same side. And I can divide everything by 2. And I get that. And fortunately that factors. That'll be x plus 2, x minus 1. So I have that x equals negative 2 and x equals positive 1. Okay, now I'm going to plug that in right here. So y, when x is negative 2, is going to be negative 1. And when x is 1, y is going to be 2. So we have two solutions. Negative 2, negative 1, and 1, comma 2. This is a line in a circle. And if we look at the graph, you can see that that line hits that circle in two places. Negative 2, negative 1, and 1, 2. So we have two ways to solve systems of equations when they're nonlinear: elimination and substitution.